We are going to talk about technology, in fact, about the state of the art of big data, or we are trying to show some examples. So as yesterday, as I explained, big data has been around for quite a long time. It has more or less more than 10 years. The 3 V's, volume, variety, and velocity, has been around for 14 years. So it has been evolving, and right now, the state of the art is big data real time plus algorithms, future data, and we are going to show some examples. But first, I would like to explain why we need this technology, why we need to jump to the state of the art of big data, not just to use big data in a classic way or previous technologies. So the real reason is this. The value of the companies, the real value of the companies is in your customers. So, and your customers, this means data. How many data do you have from your customers? Do you have enough data? Well, we are in this age for sure. And these are some of the reasons that we insist that we are in the age of customers. I will not read all of them, but some of them are quite impressive. 20% of your customers give you 80% of your revenue. 10% of your customers give you 90% of your profits. 98% of dissatisfied customers never complain. They just leave the company. And I really like this one. A very satisfied customer will tell or will talk about your company and your product to 3 people. But a dissatisfied customer will tell or will complain and will tell to 12 people. So it is 4 to 1. So really, we are in the age of customers. So we should understand the customer data. This is the question. Do I have enough information about my customers? What are we doing? What are doing the companies that are using the technology and are in the state of the art and has an advantage, real advantage in the market? Well, this is that really they are doing. They want to know about the customers. They want to know them better than their families, better than his wife or her husband. So if you are talking or thinking, okay, I am going to jump to big data, and I am going to jump to personalization, to put an example. Personalization already is old-fashioned, so you should jump to hyper-personalization, which is more than microsegmentation. So really, if you want to go there and to have a real advantage, you should jump to the state of the art of big data. For example, you need public plus private data, but you also need context. Context is very important. Context is not only positioning, it's also time. The information and the dialogue that you must have with your customers is completely different if your customer is at work or is at home. So depending of the device, to put an example, you can identify if he's working or if he is with a tablet at home, and then the dialogue, the information should be completely different. So it is, right now it is public data, private data, plus context. Where they are and what time is it. But really, this, the public data, the private data, and the context is only the surface, because it is not any longer about talking about people. The people, we live in cities, and really we are taking all the data from the cities, not only from cities, but also inside the homes. We are making some projects, reading sensors from home, detecting when the people is arriving from work, how many people is in each home, to see if they have kids, if they have no kids. So with the sensors, for electricity, for water, for anything, we are getting a lot of data about people at home. And also, this is a self-driving car from Google. I think, well, in San Francisco, you can see a lot, and it is a bit scary when you see that nobody's driving and the car is there. But it is quite impressive. These cars are with the sensors taking measuring 100 times per second. So do you think that Google is interested in the self-driving or in the car industry? Well, not really. With this, that they will have is 30 million people driving these cars, sensing the world, making pictures, seeing what is going on, and then we will digitalize the world and what is happening in the world for them. So this is only we are starting to get data. Satellites, of course, cyber intelligence is a huge data there, and the companies are not using the cyber intelligence. The dark web, we have information in the dark web that is quite impressive. Companies like Palantir that are invested by the NSA are using this type of information, and this information is something that in some degree the companies should start also using. Sensors, smart cities, Internet of Things or machine to machine is generating 50 times more data than Internet alone. So really machine to machine is part of the future. Why? Well, this is one of the reasons. One of the devices that are getting more data from us are the wearables, and especially the smartphones. With the smartphones, we are indicating things like if we are running, what we are doing, almost what we are feeling. This data is also data that we should store and use. So, at the end, the question is, how much data will I need? Well, this is some projection. Normally, in Europe, because there is a big difference between Europe and the US, a big company, has about 20 terabytes of data. For example, the big banks, the tier 1 banks, for example, the ones that are in Spain, they have about 100 terabytes. But the average for a big company is 20 terabytes. So if we go from 2015 to 2020 with 10 petabytes, this means that the volume of data that you will need to have the same competitive advantage that the companies that are already now using all that volumes of data and that information about customers, you will have to increase your current data by 100. And this is really a lot. Previous technologies cannot handle petabytes. In fact, if you see the evolution is very clear here, and you can identify or match this evolution with the technology. When we are talking about MySQL, the database, you are talking about gigabytes. If you are talking about Postgres or Oracle, you are talking about terabytes, but not a lot of terabytes. In the 10, 12, 20 terabytes, that is the limit, no more. If you go to jump to more than 20 terabytes, you have to go to MPP, to Exadata technology, or SAP HANA, or new databases. But still, they will not achieve, or they will not scale out. They will have a limit. The limit is more or less about 100 terabytes. So the only way to go to the petabytes, and I can assure you that you will need to handle petabytes, you have to jump to big data technology. In fact, some of the talks that yesterday we have with the people of SAP, they are complementing SAP HANA with SAP Bora to add the big data scale out volumes to go for this petabytes evolution that we will have for sure. So, do you have the right technology now? I am sure that most of you don't have the right technology. In fact, this is black and white, but still a lot of your companies are using host and mainframes, and well, it is not exactly that, but it is quite similar. I see some people smiling, so I am sure that you are seeing your host in your company. Banks, telecom companies, still they have this. So still, a lot of companies are in the first platform, mainframes and terminals of IT. I was explaining this yesterday. Or they are using the second platform, client server or clusters with Oracle. But the only technology that can handle petabytes, because it can scale out, is computing distribution. So it is big data and no SQL. But to jump to big data, which is that a lot of companies are doing, is not enough any longer. Why? You have to go to the state of the art, because you are not competing only with the physical companies that you were used to compete with. You are competing also with new competitors, digital ones, people that already have been there, so they have been creating this technology. They are not in personalization, they are in hyper-personalization and doing things that you cannot imagine. So to jump to use big data, Hadoop, MapReduce, HDFS, that is not enough any longer. You have to compete with those advanced weapons. Which ones? Well, this is that we think that is the second generation of big data, and this is our recommendation. Our recommendation is to combine Spark, which is a new engine for processing. We have been talking about this technology for quite a lot during the talks. Spark is a new way of processing. It's processing really, it is doing MapReduce, but it is doing MapReduce with some, in some new ways, in memory, with RDDs, in such a way that it is much more efficient. But for us, the question is not if it is faster or it is slower than Hadoop. Hadoop has been evolving, and Hadoop MapReduce is quite good right now also. The point for us is that Spark is able to combine batch, so you can do Spark MapReduce with petabytes of information, crawling and transforming that into gigabytes of insights. It is also able to do interactive. If you make a question, it is able to answer in less than 40 seconds. And it is able to process real-time streaming. And streaming for us, real-time big data, is really the state of the art. So the answer is the combination of all types of processing. Data in the past, in the big data lake, questions to that data to get insights in a discovery phase, one question, one answer, another question, another answer, insight. And data coming in the present, in real time, into your company. And above this, machine learning. Machine learning is a must. You should be using machine learning. Machine learning is the future of big data, but it is also the future of the companies. If you don't use machine learning in an advanced way, your competitive advantage will be really low, and the future will not be really good for those companies. So this is processing. But our recommendation is to combine processing with the NoSQL databases. And here we are not saying, okay, forget about HDFS. HDFS, the Hadoop file system, is a fantastic data store system. And so we recommend to use it, but to combine it with NoSQL databases. And this is that we have been doing for these years, combining this technology, processing Spark, with NoSQL databases. What is the problem about this? The problem is that although you don't have to, for processing, you are only using one engine, so you don't have to know Hadoop MapReduce, Hive, Pig, Storm for real-time, Impala for interactive. You only have to know one technology, only Spark. But Spark and the NoSQL databases, it is quite complex. So that we have been doing is to simplify the use of that combination. So just to make a summary and to put an example, because it is, I think, more graphic, that we have been doing is like a Tesla. We like to say that we are the Tesla of big data. Really is that I am trying to convince my wife to buy this car, so I am always putting this slide. Still, I am not there, but Tesla is an electric car, pure electric car. So the engine is not hybrid. It is only using electricity. So that we have done is replace the processing completely, not Hadoop MapReduce, and take a Spark only, no hybrid, not Hadoop plus Spark, just one engine. But that was not enough. The interior was also very important. The interior of a Tesla is really nice. It's like a huge tablet there and nothing else. So we have replaced also the data stores. The data stores are really important, so we have combined HDFS plus the NoSQL databases. Which NoSQL databases? Well, we can see it here, some of them. Here you can see, well, they are, not all are here. For example, we are going to see some examples with Neo4j. We really like Neo4j, and it is not there. So these are only examples, but you can see Cassandra. Cassandra is a NoSQL database. Well, I think you all know Cassandra, but scale out to petabytes really easily, and it is fantastic. MongoDB, I think right now is one of the most used databases in the world. I don't know if it is the fourth one or the third one. And of course, you can see there also HDFS. That we have built is a combination between end-to-end ingestion, real-time, the big data lake, and an SQL layer to simplify the use of this. So to use this, to use Spark plus those NoSQL databases, the question is, do you need to know, for example, for Cassandra, CQL, which is, or MongoDB API, or Spark MapReduce, or Spark Streaming? The question is not. That we have done is to do it code-free. You don't have to program to use this end-to-end platform using the state-of-the-art of big data right now. And we are going to see some examples. The first one is Sparta. Sparta, this is Sparta. We all like the movie. So what is Sparta? Not the movie, but the technology that we have built. Well, Sparta is real-time aggregation. And this is one of the myths that I always insist not to get confused about. The people, when we are talking about interactive, there is something that we are repeating, or I have heard a lot, and it is, interactive is to be able to process or to query 1 petabyte of data in less than 40 seconds, right? Well, it is really appealing, of course. All we want to process 1 petabyte to have a question, and in less than 40 seconds to have the answer. Is that possible? Well, yes, with big data technology, in the state of the art, it is possible. But you will need thousands of clusters, of nodes, sorry. So, for example, Google is able to do it, of course, but they have more than 6 million servers. So just to put in contrast, 6 million servers, what is the average number of servers that a bank tier 1, one of the biggest banks in the world, has? Like 9,000. So we are comparing 1,000 to 1, more or less. So if you have thousands of nodes in your cluster, you will be able to process 1 petabyte in less than 40 seconds. But that is not the normal situation of any big company. It doesn't matter if you are really big, if you are a big telco and you think that you have the best technology. Sorry, you don't have the best technology. And you don't have enough cluster power to process 1 petabyte in less than 40 seconds. No way. So how to do it? Well, we have had to solve this problem several times, a lot of times. And we were programming this for each project all the time. And that was the reason that we created Sparta, because we were doing the same all the time. And at the end, I think that all developers or programmers or technical guys were a bit of lazy, so we don't want to repeat the same work once and once again. So we created Sparta. Sparta is doing real-time aggregation without any need to code. And it is putting the aggregation, the cubes, the dimensions in a NoSQL database. And when I am saying in a NoSQL database, is that you can choose. You can put it in MongoDB, you can put it in Cassandra, any NoSQL database. But the raw data that is entering and that we are using to aggregate and to create these cubes, we are putting the raw data in HDFS. Why? Because HDFS, first, is cheap, really cheap. The cost per terabyte in HDFS is the lowest one, so if you want to store raw data, go for HDFS. And also it is something like indestructible. It is impossible to break Hadoop file system, or it is really, really very difficult. So raw data goes into HDFS, and the cubes, dimensions, the aggregated data go into the NoSQL databases. So if the NoSQL databases goes down because shit happens and your system will fail at some time, then you will recover the raw data and you will be able to build again the cubes, the dimensions, everything from the raw data in HDFS into the NoSQL database. So HDFS here is something like raw and a backup. So how it is working? We are using here Spark streaming, and we are getting almost any input. Any input, getting the data from ingestion, from Flume, from Scoop, from Kafka, almost any streaming. Then we are getting this data and making these cubes, these dimensions with the Spark streaming, and generating this into the outputs. The outputs could be, as I have said, Cassandra, MongoDB, or whatever. This is ruled by Kafka. So with Kafka, we can process with Spark streaming the data, but also sending the raw data, the data that was entering, to HDFS. So we are doing both things at the same time. You can see here some of the technologies, inputs, the processing, and the outputs. As I was explaining before, do you need to know Spark streaming to use this? No. It is only declarative. So you only have to type a JSON with the aggregation policy, and it will handle everything. But anyway, to type a JSON, still it was too much work. So as I have said, we are lazy people, so we made a GUI. So now, you can do it, oops, sorry, just with a GUI. Only click through and drag and drop, and you can do these roll-ups, dimensions, cubes, the typical things that you are doing in a classical ETL. You can do it with a GUI, and Spark streaming will handle all the operations. These are some of the roll-ups, some of the operators, and some of the transformations. As you can see, you could make almost any transformation, dimensions, use operators between any field. So you will have your cubes already generated. And we are going to see one example. This is a customer journey. A customer journey is, well, it is, there are different processes for customers. This is a sales customer journey. So you have touch points in which your customers are accessing your company. And from those touch points, you are moving through different stages, like discover what products your company have, information of the products, stage 2, budget, to make a budget for the product, if you are an insurance company, for example, stage 3, and at the end, to buy the product, stage 3. And here we are seeing that in each stage, you have several touch points. The main touch point for this company were web. The website was 50% of all the sales, and the call center. The call center were 45% of all the sales. So if you want to improve the customer journey, the sales customer journey for this company, where you should focus? Website, that touch point, and the call center. And all this data that you are seeing here, you are seeing the movement from a stage to the different touch points, and also the people that was quitting from one stage to the other. All this is aggregated data. So all this is showing in real time. It is changing each second. And why we can show it like this for a huge insurance company? Because we are aggregating the data in real time, creating these cubes and these dimensions in real time. So this graphic is able to read it and to show it also in real time. And no need to program the Spark streaming or to do anything complex. But as I was saying, the raw data is in HDFS. So if you make a click in any point, you can make a drill down and to go to something like drill down or a zoom into the data. So here you can see some of the drill downs, for example, for the different cities in Spain, where the data is coming, what touch points they are using, and so on. So we are accessing here the aggregated data, the cubes, and the raw data, and no need to program. And of course, real time. As I explained, for us, big data, right now, big data is real-time big data. So this was just an example, combination of Spark streaming plus NoSQL databases plus HDFS. This is a more complex one. It is complex to explain it. Imagine how complex it is to develop this. So I will just try. I will make my best effort. This is, here, yesterday there were a talk that was explaining this a lot better, but I will try to go fast. We have combined not only Spark plus the NoSQL databases, but some of the data stores to get better performance or to solve some use cases that previously it was completely impossible to solve. So, for example, we have integrated Cassandra plus Lucene. Lucene is the engine, the indexing engine behind Elasticsearch or behind Solar. So why have we done something so strange? Well, this was the reason. The NoSQL databases with the primary keys and the secondary indexes are good for when you are using or when you have high concurrency. This means a lot of users. And then these users are making questions to your big data cluster. So these questions with the primary key, you are able, with a NoSQL database, to answer these questions pretty fast. But to have a primary key, your schema has to be predefined. What happens if you are not using that for real time, for an operational application where you have developed the queries that you are going to use? So they are predefined, your queries are predefined, it is real time, it is operational, and the schema is predefined. A NoSQL database is perfect. So use Cassandra, use MongoDB, anyone. But there are several other use cases in which, for example, analytics, you don't have thousands or millions of users as in an operational application. You have low concurrency. You have maybe 100 analysts, guys making discover and queries, but these queries are like very imaginative. They can use anything. They can ask anything. They can combine any data. So you cannot predefine the schema that will solve those queries. And this is the problem that we have to the right. So how to solve this? in the same cluster, not replicating the data, not copying the data in several places. Well, the solution for us was this. We have combined, because in this scenario, the one here, with a NoSQL database, you are solving it pretty well, and that one in which you cannot predefine the queries, we are solving that with big data platforms. With Hadoop MapReduce or with Spark MapReduce, any imaginative query or think operation that the people want to do with the data, the big data platform will solve it. And so you can solve that use case and that one. But that we have done is to combine both. So in the same solution, you are solving with the same data, no need to replicate the data, any use case, any application, real-time, operational, and informational that you will find in your company. So that here we were doing was combining Spark, which is with MapReduce, you can do any query or any processing in the data, with the NoSQL databases. But the secret was this. If the application that you are using is operational and you predefine the query, it was solved already in your schema. So in that case, cross-data will ask directly to the NoSQL database the query. It will not go through a Spark. It will not use the Spark cluster because there is no need. It was already solved in the schema. So as it was predefined, you can go directly to Cassandra or to MongoDB, it will answer, and all the nodes in your cluster will be free to solve any other processing, because there were no need to use the Spark MapReduce there. And remember, you don't have 1,000 nodes. Maybe you are a big company, but you don't have 1,000 nodes, so you need all your processing. So in this case, if the schemas were solving that query, then the query goes directly to the NoSQL database. But if some scientist, data engineer, or some analyst was making some very imaginative query, thinking and combining several things, it is impossible to predefine that in the schema. So Cassandra or Mongo or any NoSQL database will not be able to solve that in an efficient way. In fact, sometimes they will not be able to solve it because they cannot handle joins or they cannot handle a specific operation. So for those cases, cross-data will get the SQL sentence and will know that the data store is not able to answer or to answer in an efficient way. So it will go to Spark SQL, will process that query in Spark SQL, will get the data from the data stores, combine it, and get the answer. So with this solution, you have the best of both worlds. Here you are using big data processing for analytics or imaginative queries, and you are using NoSQL databases directly for operational or real-time or predefined queries, okay? Not only that we are combining here is databases, but also streaming. If the data is entering in the system, because I insist big data is real-time big data, so we have in the data stores the data from the past, and it is stored in the big data lake. But we also have data in the present, the data that is entering in my company at that time. And we want also to combine this. Before we were using Lambda architectures. If someone has been working in a Lambda project, he will know how complex it was to solve this. In this case, cross-data is able to combine the data that is entered in real time with the data stored, and it is creating an ephemeral table with the data that is entering in real time. So in a single select with a join, you can make questions about the data stored combined with the real-time data entering in the system, only with SQL. So you don't have to use Spark Streaming, you don't have to use CQL, just a single query, okay? And because sometimes it is not necessary to combine this in such a way, we added to Cassandra Lucene, secondary indexes with Lucene. With Lucene, that we are having is something between those solutions. You have mid-load, mid-latency, so you can answer high concurrency with quite a lot of expressiveness. You say you can make almost any query here. So we are complementing Cassandra with Lucene to solve some intermediate cases. Which ones? Well, I will explain one very fast. And this is quite complex, but this is something that it is not very easy to solve. Indexing bitemporal data. Bitemporal data is, you combine, like in two axes, the valid time, which is the data that is real, and the transaction time. The transaction time has data that you think that is real, but later maybe you will realize that that data was not real. So with this, you are able to solve especially machine learning, because in machine learning, your system is learning between what you were expecting and what really is happening. And I will show some examples. Here, I will go directly. Here is the company sales evolution. We have made a forecasting using some algorithms, Bayesians, or anyone. And so this is a forecast. And everything is okay, but suddenly something happened, a singularity, black swan. Which one? For example, a penalty due to cheating on environment pollution test. I don't know what are we talking about. So sales go down. As sales go down, your forecasting is not any longer valid. So how to solve this? Because this is machine learning. We are learning between the forecasting and the real data. So the real data is like this. In the 4th day, the cheating was discovered. So in the 5th, 5th, and 6th day, the sales go down. So your forecasting is not valid any longer because this singularity. How to solve it? With bitemporal indexes. With this, we can use or make two types of predictions. We can start our forecasting from the day 7 after the singularity to start a normal forecasting, or you can start learning from the day 1, taking into account the singularity in such a way that if a singularity happens again, the system, the forecasting will be prepared. So this is the sample. The prediction 1 was a normal one after the 7th day. So it is making the forecasting. The dot line was the original forecasting. So as you can see, it is not any longer valid. The orange one is the prediction after the 7th day. So no singularity, you make a new forecasting and it is all right. But the system is not learning if a singularity happens again. The green one starts from day 1 and it learns and can compare the original one with the singularity. So at the end, in the forecasting, you see that they match, but you can decide which one of the systems were better. We are solving this with bitemporal indexes in which you have a data model with one version and a data model with other version. And in this way, you can decide what is the best solution for singularities. This is only an example. We will see now another one, of course, weather, the rain forecast. I think this island is New Zealand. So here you can see we are trying to forecast the data. This is the prediction, and this is the real data. So as you can see, the prediction, the forecast was not valid. So after this, we recalibrate the model to improve the next day. And this is, if today was going to be sunny, but really it was raining. So the probability for the next day to rain is bigger. So what we are doing here is this. In this axis, you have the valid time, and this the transaction time, which is your forecasting. In the valid time, after 6 hours, you can see the forecast for 6 hours, 12 hours, 18 hours, okay? But this is the data in the transaction time, the forecast between 0 and 6. So after 6 hours, that one, you already know what have happened in the first 6 hours. And that is the valid time, real data. You were thinking that the forecast of 6 hours was going to happen, but really, that was what happened. With the bitemporal indexes, we are managing the 2 data models, so we can improve with the real data the machine learning forecasting algorithm, and also we can, from that data, apply that improved machine learning algorithm to make the forecast for the next 6 hours. If you are not using bitemporal indexes, for example, this is impossible, completely impossible to solve. So I will go now to another example. In this example, we are combining Spark graph with Neo4j. Neo4j for relations for graph is fantastic, and SDFS with Parquet. So this was that we are doing. All these are real examples. So this is for a tier 1 bank. And here we were getting only the transactions in the bank, all the transactions between users, transactions, and the roles of those users. So here we were seeing what roles were related with each user. So you can see there the pink one are the roles, the users are the blue ones. If we see, sorry, I have to. Here we can see all the relations. As I was explaining, we are using graph and Neo4j to process all this. The relations between the users and the roles and how they were relating, you can make zooms. So I will go to the next one, and I will try to explain what we have done. We were using with the Spark graph, we were using something called the Jacquard Index. The Jacquard Index is an algorithm that sounds like very cool, like all machine learning algorithms. You say Bayesians and you look like a very cool guy. But really, it is very simple. It is only calculating the distance between a set of points or values and another one to see if they are equal. So as you can see here, if the intersection divided between the union minus the intersection is 1, this means that those two groups were the same. It is only that. Okay, as you will have the presentation later, you can think about this later. But trust me, it is like that. So we were using the Jacquard Index to see if the two groups were the same. With this, we were able to do this, to see what roles were the same ones. And the company had defined 25% more roles than needed because 25% of the roles defined were the same, exactly the same with different names. So in this way, in just weeks, we were able to eliminate one of its 4 roles in the company and to simplify the management and also to increase the security. And so this is a very good example. We will see it here, but the similarities were quite impressive. Here you can see all these roles are the same. So you could eliminate all of these roles and just get one. And as I was explaining, this is a combination of Spark, Spark Graph, plus Neo4j. Well, I will move. Not only this, as they were quite impressed about how it was working and how fast it was, they say, okay, why not to find out or to try to get the real organization of the bank? Because one thing is the formal organization, and another thing is the real organization. So we made and applied some algorithms, and the organization in the bank was completely different to the formal organization. So here we were seeing some thumbs, organizations, divisions inside of divisions, and so on. And it was quite impressive to see the differentiation between the real one and the one that is in the papers. As I was explaining, this was a project that only took a few weeks, and the results are quite impressive. We are applying this to a lot of banks. So, the summary. Spark plus NoSQL really reduced the time to value of big data up to 10 times. And this is one of the biggest problems of big data, complexity. So, don't go to previous generations of big data, jump directly to the second generation, and jump without the complexity. So with this, at the end, you will get something like this, moving from months to weeks, because big data projects should not be complex. It should be very easy and very powerful. So nothing else. Thank you.